Good day everybody and welcome back. So I got a fair bit done again this week, and probably it's going to be another fairly long video. I got the interceptor mechanism complete, and this boring head is now moving under its own steam. So the feed nut's been done, the adjustable stop's done, and yeah, it's all going pretty good actually. Yeah, there's a bit happened this week, been fairly busy. So I reckon one more video and this will be ready to mount up and give a trial run. Get next week at this stage. Yeah, I'm hoping at this stage next week it'll be as good as finished. And then I've got to sort out what I'm going to do about protecting all these metal surfaces, whether I cold blue it, which I don't really like the colour of that crap, or whether I send it away and get nitrite coated. I don't know what to do yet. Anyway, I hope you enjoy, and thanks for watching. Okay, this is our next part we've got to build. Well, I'm choosing to build. It's the interceptor assembly. That's what it's called. This is what puts the facing function of the boring head into gear. So the first part I am going to build is this T handle, this T section. The big radius in this corner here is 12 mil, I think it is. So 24 mil hole. So I'm going to bore that with the 2-inch boring head. I've set it up in the mill already, and I've indicated and found the center line, and I'm using this back face here as a datum. So I've worked out where I've got to be in space to do these two 24 mil holes. So, and I've already put in these two 3.5 millimeter threaded holes in the very end of it. I drilled that out 7/8, then I've just done a clean up pass with the boring head. .94, divide that by 2, so 0.47 to come out each side. I absolutely love that auto power feed on that quill. .24 on the knocker. Pretty happy with that. Okay, while it's set up in this position and I know where I am on centre and all that, there is some holes to put in. 3 holes on centre line. This first hole is a ream 6mm hole. That drill bit could do with a sharpen, I reckon. This next hole here is a tapped M6. This next one is a M6, straight M6. So now this can be taken out, set back up on its side and start milling out all this section here. This piece in the middle will end up being 14 mil. Okay, I've got an apology. I set the camera to record and I didn't realise and I didn't hear the camera beep, but it went flat. So I missed doing this. Anyway, what do? I've got to do the other side anyway. So I do apologise for that. It really just didn't miss a hell of a lot. I've still got to radius this corner here yet. Take this out now, flip it over, and hopefully machine the other side of it on camera. I've had to go back to using this regular. It's a Sterrett body and just a cheap as tip. This is a Vertex edge finder and I can't get it to repeat. It's a mile off. Like, you can set the 0, come back in, it doesn't matter how many times you do it, and it's way off. Now I pulled it apart, I lapped the two faces on flat stones, so just in case there was a little burr, and for some reason I'm just not confident with it. So I think she's time for the bin and time for a new one. A bit of a fang around with a file and that'll look as good as gold. So that's the part so far. It came up okay. Next time I have the rotary table set up, I'll radius the top of here. I could just make up a couple of button dies and put in there and file it. It's probably quicker to do it that way than it is to screw around, set up on the rotary table. Okay, this is the next part we're going to build. It's called a quadrant. There's a bit going on with this part too. Got to be super careful and get this one really correct. Okay, so the way I've decided to hold this, because I don't have a V-box suitable, I form two flats on each side, edge find off these two flats, which put me in the middle. This first rectangle that we're going to form is 16 mil wide, so I can offset 13 mil each side of centre. It's 20 mil deep, which I have 20 mil sticking out of the jaws, and I can form these two sides. This should be, theoretically speaking, right on 16. That's not bad. I'm absolutely loving this DRO. Okay, what I've done there, the top piece of this quadrant, the back end of it, where it is square, is 19mm wide. So I've put a witness mark there, because I've got to flatten the back of this off, square this off at the back here. When this squares up and it's a full square across and matches up with these corners, I've gone far enough. Okay, I've flipped apart and dusted it off. This has to be finished at a total of 26mm from the parallels, basically. So 1 inch 23 thou and 6/10 supposedly. We're at 1 inch 24 thou. We can handle that. I'm going to come in, it's a bit hard to see probably, but form the square section on the back. I know the offsets that it has to be and how far up it has to come, so that should be 19 on the money. I've just got an M5 hole to drill and tap. What we have here is a number 1 center drill. These are a ball detent. The position I'm going to do now is the neutral position. When this goes in the rotary table and has the radius put on, then it will then have another 2 holes for the forward and reverse. So this hole I end up going 1.65 deep. I've just mocked up the handle. It's got to have a proper bronze washer made to go under this shoulder bolt, and there's a handle goes through this hole. Also, this will have a touch of thread lock on here too, to prevent it coming undone while it's being used, because as you can see it wants to. But just holding it there, moving it back to the neutral position, that's a really positive lock. When I put these next 2 holes in, because they're pretty important to get the depth of them correct, because when the boring head is moving, when you're facing something off and it hits the stops, the load that comes back onto the star wheel will knock this out of gear. So you don't want this to be too rock solid when it's in the forward or reverse position, so it'll actually throw it out of gear. Okay, there was one step I forgot to do previously. This block here has to be 34mm long. I forgot to take this end off. So as you know, I don't hide my mistakes, and I've made a pretty good one here. The overall height of this part is 100% spot on. What I've done, I've taken an extra millimetre off this face here. So it should have been 20mm from there to there. It's actually 21. This should have been 6mm thick, it's now 5. I don't know why I've done it, but there is the finish where I should have, that little lip there is where I should have finished. This mistake isn't going to affect the operation of this part. It's not going to affect the way it works. I also bumped the cutter in here a minute ago and there's a slight little mark in it there. This mark here may disappear once the correct radius is put on it. So just looking at the plan and rough measurements, I am going to get rid of this mark here. That won't be left in there. So this part may just stay, even though it's not 100% correct. Let's see if I can do a half decent job of explaining what I've done here. Piece of 10mm aluminium plate, machined the two edges, decked it off in the vise. Set the rotary table up, centered off the center bore of the rotary table, clamp this plate down, then put a pocket in using this. Everything is referenced off this center hole, so I know the distance from this back edge to this front edge from this center hole, so I created a pocket that this then sits in. 3 tapped holes, M6 holes. This has to have a radius put on here, plus these edges taken off, these 2 edges. So the idea of this, the way I've done this, is this will clamp down in the center hole and I'll be able to do the radius. When I go to do the two, or remove the material off the sides, I can put the clamp to one side, rotate the table, and then I can get a clear run into the corner, and then obviously move the clamp over the other side, do this opposite side. I hope that explains what I've done here. Plus there's 2 tapped holes and there's 2 more of these really small holes. But anyway, I'm going to get this radius put on and get it to shape, then I'll worry about these other 2 holes and the other 2 tapped holes. I also, when I set the rotary table, I set it on 100 degrees. The clamps lined up better and it's easier to work out how many degrees I've got to go one side or the other from the 100 degrees. It's easier in my head anyway. Looks half right. I've decided I'm going to put in a 2 M3.5mm holes. So I've rotated the table around 34 degrees, and with this 34 degrees then it gives you an offset that you have to do on the y-axis to take these corners off. Okay, I discovered that I have made a mistake here. It's fixable. When I done this cutout, the width is right, but I was 5mm too short on this length. So when I went to take the corner off, I just done a visual with the cutter over top, and nothing was lining up. So I had to make a phone call, and then we worked out where I went wrong. So my mistake. Okay, everything should start lining up now. I've rotated the table around 34 degrees, and it's from you got a 3.4mm offset from the center of this hole. So I've done that plus half the cutter, so 8.4. I'm going to break that little bit off before it flies off. Pretty happy with that. Okay, I'm about to put the next two holes in for when the handle is engaged. This is a number 1 center drill. For when the tip of the center drill touches your job, then I'm going down 1.65mm. And it's going to be, because this is the first one that's being built, it's going to be trial and error. So this may have to be changed later on. So now I have to go 14.5 degrees the other way. Okay, this has to have two 4mm radiuses put on these two corners. I'm going to use a die to do them, just a file die. I'll machine a couple up after. Okay, I've done a little assembly here with the detent. I'm going to leave it at the depth it is, keeping in mind these are adjustable, these detents, so if you don't want as much pressure you can always back it off that whisker. Like I say, it's trial and error, but that don't feel too bad. Apart from making up a couple of file dies and rounding these corners off, there's only 2 more holes to put in here. Now the plans call for 6.4mm. I'm going to go quarter, which is 6.35, and it's got an 11mm counter bore, which I'll be using a 7/16 end mill because it needs a flat bottom. So these are for 2 M6. It's got to have a little bit of play or bit of adjustment in the holes. We've got a brand new drill. That's the only countersink I had that will fit in there against this face, which is pretty ordinary, but it did do the job. Just got to countersink them 2 other holes here on the back. Mission complete on that one. I thought I'd just show you quickly what I made up for these file dies. So that's just 8mm diameter, 3.5mm thread, a little plug that's threaded as well. Screw one in from that side, which is fiddly with my fingers. That's screwed in. And this one just simply screws on from this way. You could put these back in the collet and just nip it up if you wanted to. But yeah, and just file that off. Blend it in. Okay, this part's complete. Off camera, I machined up these 2 little silver steel pegs. You don't even have to turn the outside of it down. All you do is just turn the piece for the thread and then thread a piece 3.5mm with the die. So it wasn't worth showing that. The radius has turned out okay. It's looking pretty snazzy, I reckon. Okay, so I've rounded this end off and fitted the handle. I also made up the other 2. They're only 3/16 silver steel, just with a 3.5 thread on it. I also made up a bronze spacer. Now you make this oversize and then use a bit of wet and dry on a flat surface. I used my round table and got it to the right thickness. You got a shoulder bolt, fits on there like so. Now the idea of that, of wet or rubbing this back to the right thickness, is you've got to have minimal end float. And still be able to move freely. Backed it off a touch. Too much. It's a fine line between too much and not enough. Pretty happy with that. So that's a completed component there that needs a good clean. Okay, our next component we're going to build is this stop. Adjustable stop that goes on the side of the main body. So it's a pretty simple little part to build this one. Okay, I've got the part in the vise that's dimensionally right, length, width and height. There is a small radius in this corner here on each side, 2.5mm radius. I did have a set of parallels under here, but I did take them out because these holes are going to go all the way through. Rightio, I have stood the part up on its correct way up, if you want to call it that, Edge found the centre in both directions. There has to be like a 5mm rectangle left at the top. It does have a 4mm radius on each side of that. I've got to end up with a 3mm flat at the bottom as well. It'll all come clear when it's done. You'll know what I've been trying to say. So this has to have a 4.2mm wide slot each side. It is going to be hard for you guys to see putting this slot in because there isn't a lot of room. This is a 4mm cutter. The end's pretty buggered on it. It's the only one I got. See how it goes. Now before you all start nailing me, it's not the right way to do it, and I should have done this before I started. This should have been the first operation I done, was 2 radiuses 1.5mm corners. So I'm going to dodge it up and try and do it this way. Okay, you see me do 1 radius quickly. I slipped around and done the other 3, but they may not be perfect. The part may not be 100% perfect, but it's pretty bloody good, I reckon. So that can be put on the boring head now, and it'll make sense. Okay, I've got this adjustable stop fitted, so it can be moved. You got 10mm of adjustment that way. You can move it up to this set of holes as well, and there's another position there you can put this post in. So if you're feeding back the other way, you can make that as a stop. You pretty much got stops all the way along its travel. It don't look too bad, eh? Next part is the feed screw nut. I think I've got a plan on how to build it, but it is pretty important where the depth of this stem or this face here in relation to that the 10x1 thread. Got to get that pretty spot on. So this is made out of bronze. Our first dimension we need is 10mm for a length of 15. And that's going to have an M6 thread up its dot. I'm just thinking I might put that M6 thread in there now, just in case when this is 10mm, and drill it and tap it, it may swell it a fraction. I don't know, it may not, but .99. It can be nominal 10 with an F7 or F8, sorry, tolerance, which is 9.97 to 9.99. For a length of 5mm from this face, it has to be down to 9.9. Okay, this 9.9mm dimension had to be 9.9. Well, we're just under the 9.9, so yeah, 0.005 if you want to call it that. This can come out and go into the mill in a collet block holding onto this 10mm diameter. I think before I put in the mill, I am going to turn this around, hold it by this diameter and part this excess off. So I'll explain what my theory is here. The length of this boss, if you want to call it, has to be 14.5. I parted it off over length, faced it off. Now I've got the measurement, which is 17.33. So once I can bring that to dimension now without having to just fluff around and take it out and measure it. Okay, this is about the best I can get it. That's going to have to do that, so start forming the square now. $16.01, I'll leave it at that. I'm pretty happy with that. Okay, I've got a 2mm radius ball nose end mill, if you want to call it that. Has to be a slot put in Now this is where the oil will go down and feed into the feed screw. 8mm long, 2mm deep, so I'm just going to see how we go here. Okay, that's that part in. Now it does have to be a 3mm hole drilled down, which intersects with the threaded 10x1 hole that will be in there next. But I'm thinking I may put that in after I put this thread in. I have two 10x1 taps. These are out of a King Chrome set I own. I don't know really honestly what they're like, but I'm going to find out pretty directly. It actually don't look too bad, that thread. Okay, I've set it back up in the vise to just pop this 3mm hole back through. And that looked just pretty. Give that a good clean out with some brake cleaner. And that part's finished. Okay, so it's in there. Happily fits and screws all the way in. So I'm going to assemble the slide onto the base and bolt all this back up. There's a 6mm cap head bolt through that side, it's what retains it. It's not obviously done up tight yet, but I'll get it together and see if it actually all works. Well, here's a bit of good news. We have success. What, the nuts done up tight, bearing housings done up tight. So I must have hit the numbers pretty good. That's an achievement, eh? That wasn't a bad effort this week to get all this made. It was yeah, it was quite interesting really, and it's finally awesome to see this moving by itself. And yeah, I'm pretty happy, pretty happy. I still have to broach the keyway in the star wheel, and I still haven't got my 3mm cutters to do the key in the feed shaft. So yeah, still got to do that. But apart from that, we're getting pretty darn close. Like next week, I reckon it'll be mounted to the mill and ready to do its first spin, which will be pretty exciting. Anyway, I hope you guys enjoyed this week's video. Yeah, it's another long one, but getting a fair bit done. Anyway, see you all next week. Hooroo.